All right, this is long division 3a. So if you notice on the original test, the problem was already set up for you. The focus of this problem really is to determine whether or not x minus 1 is a factor of this polynomial. And in order to do that, we have to divide. So I'm going to divide first, and then we'll talk about whether or not it's a factor. So x goes into 2x squared, 2x times. I can multiply 2x times x, I get 2x squared. 2x times negative 1, I get negative 2x. And I'm going to subtract this, and when I subtract, everything gets subtracted, not just the 2x squareds. So I have negative 5x minus negative 2x. I end up with negative 3x. And then I'm going to bring down this 10. And then I repeat the process again. X goes into negative 3x negative 3 times. And then I can multiply my negative 3 times x. And I can multiply my negative 3 times negative 1. And again, this whole thing is going to be subtracted. So I have a negative 3x minus negative 3x. It cancels out. And 10 minus 3 is 7. So I have a remainder of 7. So again, back to the idea of whether or not this is a factor. In order for something to be a factor, it would need to go in evenly or perfectly. And this one doesn't. It goes in 2x minus 3 times, but it has this leftover of 7. So if you have a leftover, it is not a factor. So no, this is not a factor, and it's because there is a remainder. In order for something to be a factor, it would have to go in evenly. So go ahead and move on to 3b.